Hey class, Mr. Hanji here. For today's lesson, we are going to be taking a look at section 1.2, which is going to deal with modeling quantities. Now, for today's lesson, we only have one learning goal, and that is you will be able to use rates, ratios, and proportions to solve real-world problems. So we're going to go through and talk about those three different things. We're going to talk about how they apply and how we can use them in everyday life. So with that said, let's go ahead and take a look at our first couple. So ratios and proportions are very useful when solving real-world problems. A ratio is a comparison of two numbers by division. So an example of a ratio would be something like 3 to 5, which we can write as 3 over 5. Now, an equation that states two ratios are equal is called a proportion. So an example of a proportion would be like 1/4 equals 3/12. There are two different ratios, and they are equal to each other, and they're set equal to each other in this problem, and that is a proportion. Now, we're going to use proportions throughout today's lesson to help us solve and find different lengths, convert different quantities measurements, and also use it to do some dimensional analysis. So with that said, before we jump into our first example, I kind of want to give us a pre-example to get some practice in with proportions. So what this states is a totem pole that is 90 feet tall casts a shadow that is 45 feet long. So we have a 90-foot tall totem pole that is casting a shadow that is 45 feet long. At the same time, a 6-foot tall man is casting a shadow that is X feet long. So this man is looking at the totem pole, he's 6 feet tall, and he casts a shadow that is X feet long. What the problem asks us is what is the value of X, meaning we need to go through and figure out the length of the man's shadow. So what we're going to do here is use proportions to help us set up a problem that we can go through and solve for the man's length of his shadow. All right, so with that said, the key thing here is setting up our proportion. Now, when setting up a proportion, there's a couple ways you can do it. You just have to keep the same pattern for each ratio. So, if I want to do a ratio of the totem pole, I could do the height over the shadow, so it would be 90 over 45. That means I have to follow the same pattern for the man. So that means I have to do 6 over x. Now, if I want to do a ratio of height over height, it would be 90 over 6, and then I could do 45 over x. Whichever way you want to do it works, and you will get the same answer. The thing that you just need to be careful with is that you follow the same pattern. Okay, don't jump to something different. Follow the same pattern. Now, for this problem, I'm going to follow the pattern of the height over the shadow of each object. So the top part is going to be the height of the totem pole, or the height of the man. And the bottom part of each of our ratios is going to be the shadows. So, following that format, that's how I'm going to set up my proportion for this problem. So if it's height over shadow, let's start with the totem pole. That's going to be 90 over 45. And then my ratio for the man, since it's height over shadow, it would be 6 over x. So my proportion is 90 over 45 equals 6 over x. Now, in past math classes, you should have talked about proportions, but in case you have forgotten, okay, to go through and solve a proportion and find a missing part, is we're going to use a method called cross-multiplying. So cross-multiplying means that we're going to go across the equal sign and from top to bottom or bottom to top. So to cross-multiply, we're going to go through and do 90 times x across the equal sign equals, and then we're going to do the other set, and that's going to be 45 times 6. So I have 90 times x equals 45 times 6. Now, if I go through and simplify this, 90 times x is going to be 90x. And then if we go through and do 45 times 6, go ahead and pull out your calculator. We do 40 times 6, or 45 times 6, sorry. We end up with 270. So I now have 90x equals 270. Now, something that we talked about in the previous section is when you have 90 times, or 90x, that implies 90 times x, so it implies multiplication. So the inverse operation is division. So we're going to divide 90 to both sides. So 90 is going to cancel out on the left. And then we're going to have 270 divided by 90, which is going to give us x equals 3 feet. Meaning the man's shadow is 3 feet long. So that is an example of how to set up a proportion and then go through and solve it by using cross multiplying. Now, through today's lesson, we're going to carry a lot of those similar ideas throughout each problem. Now, before we move on, I just want to make a quick note, okay, because I mentioned there's multiple ways you can set up proportions. Okay, another way that we could have set this up is we could have done, instead of height over shadow, we could have done height over height and then shadow over shadow, meaning I could have done 90 over 6 and setting that equal to 45 over x. So that's another way that you could go through and set up your proportion. If you went through and solved that, you would get the same answer. And something else is it doesn't matter what's on top or on bottom, you could flip those as well. The one thing you cannot do is you cannot break the pattern. So I couldn't do the height of the totem pole over the shadow of the man. Okay, if that violates our pattern. So you can do height over shadow, or totem pole over man, totem pole over man. You just have to keep the same pattern. All right, so with that said, we're then going to go move forward and use proportions to help us solve stuff for example 1. Now, we are going to talk about scales in terms of scale drawings and models, so let's talk about that before we jump into example 1. So, a scale is the ratio of any length in a scale drawing or model to the corresponding actual length. So, a drawing that uses a scale to represent an object as smaller or larger than the original object is a scale drawing. An example of a scale drawing would be a map of Michigan. Okay, it's smaller than the actual state and it is actually scaled down. And oftentimes in maps they provide a scale, so it would tell you something like 1 inch on the map equates to 50 miles in real life. Okay, so that's an example of a scale where the first number relates to the distance on the scale, drawing, or figure. And then the second number is going to relate to the real life measurement. Now, a three-dimensional model that uses a scale to represent an object as smaller or larger than the actual object is called a scale model. Examples of scale models would be a globe or a toy car or anything else, say like a dollhouse, would be an example of a scale model. Okay, it's either going to be smaller or larger than the actual thing, and it's going to be scaled up or down for various reasons. Now, using scales, we can go through and find either given a certain measurement on a map, how far it is in real life, or knowing the distance in real life, how far it is going to be on a map. So, example 1 is going to ask us to use the map to answer the following questions. So for part A, it states that the actual distance from Chicago to Evanston is 11.25 miles. It wants to know what is the distance on the map. So in real life, Chicago to Evanston is 11.25 miles. So from Chicago to Evanston, it's 11.25 miles. Now the question asks us how far, or what is the distance on the map from Chicago to Evanston. Now, on the map they provide us our scale, which states 1 inch is 18 miles. For every inch on this map, it equates to 18 miles in real life. So with that said, when you are going through and using anything that relates to scales in today's homework, whether it's a map, it's a scale model, or drawing, you want to follow this format. Now, how I usually go through and set it up is I start with this idea of the map or the scale drawing or model over the actual distance. Okay, and what I'm going to do is start with the scale. So the scale tells me for every inch it's 18 miles. So for 1 inch on the map, it's 18 miles in real life. So that's my first ratio. Now to set up a proportion, okay, we're going to set this equal to. In the problem, they tell us that the distance in real life is 11.25 miles, and it wants us to know what the distance on the map is. So in real life, the distance is 11.25 miles. So that's the actual distance. So we're going to put that on the bottom. And it wants us to figure out what the distance is on the map. So to symbolize that, I'm just going to use x as a placeholder until we can figure out what that value is. So it's 1 over 18 equals x over 11.25. So with that said, we then need to go through and cross multiply and then solve to figure out what the distance on the map is. So first step in cross multiplying, let's do the multiplying part. So we have 1 times 11.25, which is 11.25. And that is going to equal 18 times x, or 18x. So I now have 11.25 equals 18x. I then just need to go through and solve this, and just like what we did above, to solve it we need to go through and divide. So the inverse of what's happening is division. So we divide 18 to both sides. We pull out our calculator. So we're going to do 11.25 divided by 18. And when we do that, we get 0.625 for our value of x. Meaning the distance on the map is 0.625 inches. So in real life, Chicago to Evanston is 18 miles, and on the map, the distance from Chicago to Evanston in real life is 11.25 miles, and on the map it's going to be 0.625 inches. So that is a way to use a scale and then proportions to help us to figure out either a distance on the map or a distance in real life. Now, part B is going to ask us to do the same thing, but we just have 2 different places and different distances. So in this case, it's North Chicago and Waukegan, and it's 4 miles. I'm going to leave this problem for you to do if you want some extra practice. It is just like what we did in part A. It's just different numbers and different spots. But I will leave that for you if you would like some practice. Now, moving on to save some time, I do want to take a look, though, at part C, because part C is not talking about a map, but it does talk about a scale, and I just want to address that before we move on. So for part C, it talks about a scale model of a human heart is 196 inches long. The scale is 32 to 1. How many inches long is the actual human heart? So a model of a human heart is 196 inches long. So it's much larger than the actual human heart, but this is a model. And the scale is 32 to 1. So it wants to know what is the actual length of a human heart, and that's what we're going to go through and figure out. So first thing is we're going to start with our scale. So our scale in this problem is 32 to 1. And just like we did with the map, where it was the map over the actual, for this we're going to do the model over the actual. Okay, the first number in our scale is the model, and then the second number is going to be the actual for the scale. So that means we're going to have 32 over 1. And then that's going to equal, because the scale model of the human heart is 196 inches, we're talking about a model. So the model goes on top, so 196. And we're trying to figure out how many inches long the actual human heart is. So we're going to put that over x. So I now have 32 over 1 equals 196 over x. So at this point, you'd go through and cross multiply and solve. To save time, I'm going to leave that for you to go through and do on your own. As always, like with part B and for finishing with C, you can always look at the completed notes if you would like to see how I did it, or you can just ask next time you see me, and I'll be more than happy to explain it to you. All right, so I will leave that part for you to go through and solve. Now, before we move on to the next page, there is a part down here that talks about dimensional analysis. So I want to go through and talk about what dimensional analysis is before we jump into the stuff on the back. So, dimensional analysis is a method of manipulating unit measures algebraically to determine proper units for a quantity computed algebraically. Alright, so that was a whole bunch of different words that might not have made a lot of sense. Dimensional analysis just means that we might go through and change the unit measures, so that way we can go through and compare stuff a bit easier. For example, if we were to talk about something in terms of kilometers, okay, for us, kilometers is a little bit harder to understand than something like miles or feet. So dimensional analysis would mean we would change the units to something we would understand better, or we change the units to match so we can compare two quantities. Okay, if I asked you, is 2 gallons more than, say, 16 quarts? Okay, gallons and quarts are two different measurements. It's something we're not too familiar with. So that would be something where we would go through and try to compare, so we try to match the units. So we are going to go through and do some different conversion factors with rates, and that's going to be where we start with example 2. So on to the next page. Example 2 is going to ask us to use dimensional analysis to convert the measurements. Okay, so if we look at example 2a, for example 2a, it talks about a large adult male human has about 12 pints of blood. It wants us to convert the quantity to gallons. So on average, a large adult male has about 12 pints of blood, and we want to go through and convert that to gallons. Now, what I want you to understand at this point, when we are talking about conversions, converting something, or dimensional analysis, okay, we're going to have to flip a little bit of our thinking. Okay, with proportions in terms of scale, models, or drawings, you kept the same format, meaning map over actual, model over actual. Here, because we are changing units and we're converting to different units, we need to go through and cancel stuff out, so we have to do the opposite. So instead of keeping things on top and on top, or on bottom and on bottom, we have to do the opposite. So if something is on top part of a fraction here, it needs to be on the bottom on the second part. Or if it's on the bottom, it needs to be on top on the next part. That allows us to cancel it out. Alright, so if our starting point is the fact that we have 12 pints of blood, okay, so we're going to start out with 12 pints. And to set up a fraction, because it's sometimes helpful, we're just going to put this over 1. Okay, we're not going to put a quantity for 1, we're just going to leave it as 1. Now, it wants us to convert the pints to gallons. Now, if you do not know different conversion rates, like how much of 1 gallon is a certain amount of pints, you can always look up online what the conversion factors are, and that will give you some guidance on how to do these. So, I do provide, though, for this problem that 1 gallon equals 8 pints. So for every gallon, it's 8 pints. And I'm wanting to switch this to gallons, and I want to get rid of pints because that's what I have right now. Now, for converting measurements, okay, we are not going to set this equal to like we did with scales. We're actually going to multiply fractions. So that's what we're going to start with here. Now, the key for conversions is you need to do the opposite. So we have 12 pints on top. That means I need to put the pints value on the bottom. So you have to do the opposite. So that means we're going to put 8 pints on the bottom. And then that's going to equate to 1 gallon. And that's what we're going to put up top. So you have to do the opposite. Okay? Instead of doing pints over, pints on top, we have to do the opposite because we're going to go through and cancel out units. All right, now when multiplying fractions, just as a reminder to you, when you multiply fractions, you multiply top to top and bottom to bottom. So if we go through and do this, if I have 12 times 1, I get 12. And then if I do 1 times 8, we get 8. Now, before we kind of move forward, okay, just taking a look at the units, because I have pints on top and on bottom, they cancel each other out. And gallons is just on top, there's nothing on the bottom. So that leaves me with 12 gallons over 8. Now, this is a point where we can go through and simplify this fraction and actually divide. So if I go through and do 12 divided by 8, I get 1.5. Meaning that 12 pints equals 1.5 gallons of blood. So, something that's easier for us to think about is gallons, and that's why here we went through and did that conversion because it helps us think about it easier. So that is how we're going to go through and convert stuff. Again, instead of setting up a proportion and setting them equal to each other, we're going to multiply fractions, and we have to do the opposite to cancel units out. So let's go through and practice one more, as it might be helpful to see another one done. So for part B, it talks about the length of a building is 720 inches. It wants us to convert the quantity to yards. So we're going to go from inches to yards. Now, I do provide that 12 inches equals 1 foot, and that 3 feet equals 1 yard. So those are kind of some basic understanding of stuff. Now, you could go through and convert it from inches to feet and then feet to yards. You just have to do 2 different conversions. Now, to simplify that and make it a little bit quicker for us, okay, another thing we can think about is that 36 inches is in 1 yard. So 36 inches equals 1 yard. Knowing that conversion factor, that conversion rate, will help us go through and solve this a bit quicker. So we start out with the fact the length of the building is 720 inches. Again, I'm going to put that over 1 because there's nothing else with that part. Now, I'm wanting to convert it to yards, so we're going to do times. Now, I know there's 36 inches in every yard. Because I have inches on top here, it means I need to have inches on the bottom in the second fraction. So that's going to be 36 inches, and then 1 yard. So I now have 720 over 1 times 1 over 36. Again, multiply top to top, bottom to bottom. So that's going to be 720 over 36. And then because I have inches on top and on bottom, we cancel those out, and we're left with yards. So I've now successfully converted it from inches to yards. We just need to get a nicer looking number. So we're going to go ahead and do 720 divide by 36, and we end up with 20. Meaning 720 inches equals 20 yards. So that is two ways that you can go through and convert stuff. Few things to keep in mind, okay? Unlike with scales, where you do the same thing for each ratio, you keep the same pattern. When we're talking about converting measurements, okay, or ever changing a unit, you have to do the opposite. So you're going to multiply instead of setting them equal, and you need to have the opposite to cancel them out. So pints on top, then you need to have pints on bottom. Inches on top means you need to have inches on bottom. Okay, that way we can cancel out the units, thus getting rid of it and bringing in the new unit we want. The other thing is I did provide you guys with your different conversion factors, where 1 gallon equals 8 pints, 36 inches equals 1 yard. I do recognize that there are some times the problems don't provide you with the unit rate or the conversion factor. That is something that you could go onto Google and you could type in how many inches are in a yard, or you could type in how many pints are in a gallon, and it will go through and tell you. Something I also recognize is that you could very well likely go to Google and you could type in how many gallons is 12 pints of blood, or you could type in how many yards is 720 inches, and it would go through and convert and do it for you. Okay, I am just going through and showing you how you actually convert stuff. But be aware of the tools that you have in ways that you can go through and convert stuff that might be a bit simpler. This is just how you would go through and do it by hand. Alright, so we're going to use the idea of how to convert stuff with our next example, and going through and comparing stuff with dimensional analysis. So, example 3 is going to state, during a cycling event for charity, Amanda traveled 105 kilometers in 4.2 hours, and Brenda traveled at a rate of 0.2 miles per minute. Now the question asks which girl traveled at a greater rate. So you would have to take what they give you and determine which one traveled at a greater rate. The problem is that for each of the girls, it provides a different measurement. Okay, kilometers is a much different measurement than miles, and hours is different than minutes. So what we need to do is we need to choose one of these girls to go through and change their rate or their speed to match the other so we can compare it a little bit easier. Now, for this problem, I'm going to use Amanda's speed of 105 kilometers in 4.2 hours. And what we're going to do for this problem is we are going to convert kilometers to miles, and we're going to convert hours to minutes. So that's going to be our goal for this problem, is that I need to change this to miles and I need to change this to minutes. By doing so, we would end up with the miles per minute, like the rate that Brenda has. And then we can compare and see which one was faster. Alright, so first thing we're going to do is we're going to take this 105 kilometers in 4.2 hours, and we're going to set up our fraction. So we're going to have 105 kilometers per 4.2 hours. Okay, think of this as like miles per hour, but we're just talking about kilometers. Alright, now I do provide the conversion rates of that 1 mile equals 1.61 kilometers and 1 hour equals 60 minutes. So we just need to do one step at a time. So let's first start by changing kilometers to miles, because we are converting units. Again, we're not setting them equal, we're going to multiply fractions, and you need to do the opposite. So I'm wanting to switch kilometers to miles. So I need to get rid of kilometers for the unit. So I know that 1 mile equals 1.61 kilometers. So kilometers on top means kilometers have to go on the bottom. And then the other part of my conversion factor is 1 mile. So then 1 mile goes on top. So if I go through and set this up, you remember when multiplying fractions, it's top to top, bottom to bottom. So I end up with 105 on top. And then if we do 4.2 times 1.61, okay, we're going to end up with 6.762 as our number. So this is going to be 6.762. Now, if we go through and take a look at the units, okay, my kilometers cancel out because top and bottom, and I'm left with miles over hour. So I now have 105 miles per 6.762 hours. Now, we're close because we can relate miles and miles, but for Brenda's rate, it's talking about minutes. So that means I need to change this hours to minutes. So we have to go through and do another conversion here. So again, it's multiplying. Now I'm wanting to switch hours to minutes. So I need to cancel out this hours. Now we know for every hour there are 60 minutes. And because I'm wanting to get rid of hours because it's on bottom here, I need to put the hours on top. So we're going to have 1 hour on top. And then the other part, 60 minutes, is going to go on the bottom. So again, multiply top to top, bottom to bottom. So I have 105 times 1, which is 105. And then if we do 6.762 times 60, we're going to end up with 405.72. Now, if we look at our units here, so the hours have canceled out because I have it on top and bottom, and then I'm left with miles and minutes. So I have 105 miles per 405.72 minutes. Now, I have my same rate now of miles per minute, but we need to go through and actually divide these to go through and compare them. So if I go through and do 105 divided by 405.72, we end up with, and I'm going to round here, approximately 0.26 miles per minute. So this is Amanda's rate. So she went 0.26 miles per minute, and Brenda traveled at 0.2 miles per minute. So which one is faster? Well, Amanda's speed is faster by 0.06%. So that means Amanda was faster than Brenda. So that is a way that we go through and use conversion to then go through to get similar rates. So that way we can compare speeds or we can compare amounts easier. So that is example 3A, and that is how you would go through and convert two different units. All right, now part B of this is going to ask the same thing, but just different situation. So it talks about a box of books, weighs a certain amount for each meter of its height. I'm going to leave this one for you to do for practice, or by all means take a look at the completed notes to see how I went through and did that for a little bit of guidance. If you have questions on this, please do not hesitate to ask. Okay, it can be a little confusing about how to set it up and start to run through it. When you run through it a few times, it should be a little bit easier for you. All right, so we have one more thing to look at, and then we are done for today. So example 4 is going to ask us to go through and graph a proportional relationship, find the unit rate, and then create scales and graph. So the situation for example 4a is that Alex drove 135 miles in 3 hours at a constant speed. So what it wants us to do is go through and figure out a unit rate. A common unit rate in this case would be miles per hour. So if that's the case, we're going to go through and set up a ratio. So we have 135 miles in 3 hours. Now, to figure out our unit rate, instead of just leaving it as that, we are actually going to go through and divide. So we're going to do 135 divided by 3, and we end up with 45, meaning he drove 45 miles per hour. And 45 miles per hour is going to be our unit rate. Okay, so 45 miles per hour is our unit rate. Now, it wants us to go through and graph this situation for what it has asked. So, if we're going to go through and set up our graph, okay, x is going to relate to time and y is going to relate to distance. So, we are talking about miles and hours, so our time is going to be hours. And then our distance is going to be miles. All right, so if we're going to go through and set up our scales to graph, okay, we're going to start at 0, and then I'm going to skip every other one for hours, so it would be 1, 2, and then 3. And then I'm going to go up in increments of 45 by skipping, so it would be 45, 90, and then 135. So for every hour, okay, the 45 miles per hour means for every hour, he's driven 45 miles. So at 1 hour, it's 45 miles. 2 hours, it's 90. 3 hours, it's 135. So then we go through and connect our dots to draw our line. And our graph looks like that. So if you're asked to find the unit rate, okay, unit rate means that you actually need to divide the two numbers to figure out your rate. So in this case, we have miles and hours. We're going to do miles divided by a certain amount of hours. And that is how you go through and figure out a unit rate, and then go through and graph that. All right, so with that said, that is the end of our lesson for section 1.2 on modeling quantities. Something I want you to be aware of, 1.2 for our purposes is the end of module 1, meaning expect a quiz to be coming up here very soon. So something to just be aware of as you're working on your stuff today, to be sure to go look back over section 1.1 and then 1.2 to be ready for your quiz. All right, so that is all that I have for you guys today. I hope you feel pretty comfortable with this. If you have any questions, please do not hesitate to ask. Otherwise, that is all that I have for you guys today. I hope you have a great day, and I will talk to you later.